Hey guys, how are you? So we're on lesson 7, and today we'll be dealing with word problems. And you'll notice that some word problems can be solved by using the Pythagorean theorem. So today we will be drawing a diagram that represents a situation, and we'll see that it creates a right triangle. Therefore, we can use the Pythagorean theorem to answer the final question. So there's a do now. There's some classwork problems that if we were in school, I would do numbers 2, 5, 6, 7, and 9 with you, and then you would finish the rest with your partner. So I'm going to do those 5 questions first, and then I'm going to ask you to hit pause and maybe try the other ones and then check your answers with me. Um, and then you'll have the problem set to do and then check the answers at a future date when Mrs. Lawton and I post the answers. So make sure you do check your answers to your homework from lesson 6 to make sure you're ready for today's lesson. So the do now is a word problem, but the diagram is drawn for us already. It says that Tanya runs diagonally across a rectangular field. So you see a rectangular field here, and then this diagonal line is her running across the field. And it says across a rectangular field that has a length of 40, so the length of the field is 40, while the width is 30. And we want to know the length of that diagonal that she ran. So instead of going around the outside of the field, if she ran around the outside of the field, she would go a total of 70 yards. But if you go diagonally across, she should be saving herself some time. I actually noticed that this is one of the Pythagorean triples. Remember, there's a thing called a 3, 4, 5? Well, any multiple of 3, 4, 5 is also a right triangle. So I see a 30 and a 40 given to me, so the diagonal is going to be 50. But let's use the Pythagorean theorem to prove that. We would do a squared plus b squared equals c squared. And since this is the right angle, the x is your c. So I'll call this a and this b. So 30 squared, my pen's not working proper right now, plus 40 squared equals x squared. So this is 900 plus 1600 equals x squared. So this is a 2500 equals x squared. To undo squaring, you square root. The square crosses out the square root. So x is the square root of 2500, which really is 50. 50 times 50 is 2,500. So the length of the diagonal yards is 50 yards. So let's do the problems that I spoke about. Number 2, you have a 15-foot ladder and need to reach exactly 10 feet up the wall. So I guess you must have some kind of building with a wall, and the ladder is like leaning against that wall. So here's my ladder. It's a 15-foot ladder, so that diagonal is 15, and I have to reach exactly 10 feet up. So from the ground up, this is 10, and walls make right angles with the floor. So I know that this 15 is actually my hypotenuse, my C. It's asking how far from the wall should you place the bottom of the ladder. So they're asking what this distance is. So we can call this A and this B, and then that 15 is C. So if we use a squared plus b squared equals c squared, we can write x squared plus 10 squared equals 15 squared. So x squared plus 10 times 10 is 100 equals 15 times 15 is 225. We're trying to solve for x, so I have to get rid of this plus 100. The opposite of plus 100 is subtract 100. Whatever you do to one side, you do to the other. So x squared is now equal to 125. Do you notice the hint here? Round your answer to the nearest tenth. I guess when I take the square root of both sides, the square root of 125 must be irrational because of the hint of rounding. So if we take a look at our calculator, the square root of 125 is about 11.2 when rounded correctly. 11.2 feet. So how far away from the wall should you place the ladder? Place the ladder about 11.2 feet away from the wall. Let's do the next question that I wanted to do. Number 5. A baseball diamond is a square with sides of 90. What is the shortest distance to the nearest tenth of a foot between first base and third base? So here's first base, here's third base. The shortest distance is always a straight path between the 2 points. So since this is a square, there's a right angle here, and that shortest distance is across from a right angle, which really means it's the hypotenuse, it's C. It's like I know the legs, A and B. So a squared plus b squared equals c squared. So 90 squared plus 90 squared equals c squared. This is 8100 plus 8100 equals c squared. This turns out to be 16,200 is what c squared is. To undo the square, you square root. Whatever you do to one side, you do to the other. And we use our calculator, and the square root of 16,200 is that, it says round to the nearest tenth, so 127.3. I'm going to actually change this to a squiggly equal sign. It's about 127.3. The shortest distance between first and third is about 127.3 feet. Next, number 6. A computer monitor is listed as being 19 inches. So whenever TV screens, computer monitors, and things like that, whenever its size is listed, they always give you the diagonal length. So here's something that can represent my computer monitor. This here would be the 19 inches. If the screen measures 10 inches in height, so this I could say is 10 inches, what is the actual width? So how wide is this here? I'm going to put an X. Now it's a rectangle, so here's a right angle. Across from the right angle is the hypotenuse. So 19 is your C. We can call 10A and the XB, right? So when we do A squared plus B squared equals C squared, it's the 19. That's my C. The A and B doesn't matter. I'll write 10 squared plus, I'll call it an X squared equals 19 squared. So 100 plus X squared equals, I'm not sure what this is, 19 squared, 361, solve by subtracting, x squared equals 261, square root both sides, x is about, this is to the nearest inch, that's like to the nearest whole number, the square root of 261. About 16. About 16 inches wide. Number 7. A carpenter wants to build a handicap ramp over a set of steps that's 12 feet long and 5 feet high. How long will the ramp be? So this wording can sometimes be a little confusing, right? It's, maybe there's a house that has stairs that go up to the door, right? And here's the ground. So he's building a ramp right here so that a handicapped person in a wheelchair can get up. So it says over a set of steps that's 12 feet long. They're talking about this length here being 12 and this height here being 5. Because they say, how long will the ramp be? They're actually talking about, like, this piece of wood or whatever it is he's making it out of. So the x is my hypotenuse. So 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. 169 equals x squared. Square root both sides. Square crosses out the square root. X is the square root of 169, 13. Turned out to be a whole number. So this is actually another Pythagorean triple then. It's not as famous as the 3, 4, 5, but did you notice that 5 is a whole number, 12 is a whole number, and 13 is a whole number? Anytime you use the Pythagorean theorem and the legs and the hypotenuse all turn out to be whole numbers, they then call it a Pythagorean triple. Because it doesn't happen very often. Usually when you take the square root, maybe I shouldn't say usually, but very often when you take the square root of a number, it turns out to be some crazy decimal, right? There aren't as many perfect squares as there are non-perfect squares. But anyway, the answer is that the ramp will be 13 feet. Number 9, Oscar's doghouse is shaped like a tent. The slanted sides are both 5 feet long and the bottom of the house is 6 feet across. What is the height of his doghouse in feet at its tallest point? So shaped like a tent, I assume they're talking about a shape like this. That reminds me of a tent. And the slant sides are both 5, so I think they're talking about these sides are both 5 feet long. And the bottom is 6. What's the height of his doghouse? So they're talking about this straight line down the middle. So when you draw that straight line, you make right angles. So it's like 2 small right triangles. I'm going to draw the front of his house a little bit larger. So this whole thing is 6. These sides are 5. And this is what I don't know, but there's a right angle here. If the whole thing at the bottom is 6, and both these sides are the same, it means it's an isosceles triangle, which means the base is split into 2 equal parts. So I'm just going to look at this one triangle here and notice that one of the legs is 3, and notice that the hypotenuse is 5. Do you know what the other leg is? Yeah, it's a Pythagorean triple. The other leg is 4. 4 feet tall. And I use the fact that it's a Pythagorean triple. You could use the Pythagorean theorem and you'd get the same answer. So those are the ones that I would have done in class, and then I would have asked you to work with your partner. So you could try a few. I'm going to do them and then share the answers with you so that you could fix any problems that you have. So why don't you give it a try first before you check your answers with me. So as I'm going through these answers, you can pause, of course, when necessary to copy down some stuff if you didn't get it. So number 1 was pretty straightforward. It was a right triangle that you had to just label correctly so that you knew the hypotenuse was 15. You could see my work, and I got an answer of 81 centimeters. Then number 3, you had to be careful of your picture. So you can see that I put the kite up here, I put the stake, attached it with the string that was 650 feet long, put Shari underneath the kite and showed that she was 600 feet away from the stake so that I can use the Pythagorean theorem and find out that the kite was exactly 250 feet high. Turned out to be a nice whole number. Number 4, I thought was pretty straightforward because the triangle was here, the hypotenuse is 9, and it turns out to be about 5.7 feet tall, that ramp. And number 8, again, pretty straightforward to begin with. You had to be careful, though, that they asked for perimeter and area. So I wrote that first, you need to find the side. So I used the Pythagorean theorem to find that the missing side, or the length of that rectangle that I drew, was 16. Once I know that that side's 16, of course the side opposite of it is 16. They told me one side was 12, so the side opposite of it is 12. Perimeter means add up all the sides, so I got a perimeter of 56 feet, and then area of a rectangle is length times width, so I did 16 times 12 to get 192. Then I thought 10 was a really tricky one. Also, I wish 10 had told us to round to the nearest tenth, because it is not, they are not rational answers. And to find the length of BC, I had to look at these two separate right triangles. And the numbers are in a weird spot too. I wish the 3 was maybe a little bit up, whatever. It's not a Pythagorean triple, because I do see a 3 and a 4, but the 4 is the hypotenuse. Remember, the 3, 4, 5 right triangle, 5 is the hypotenuse. So I did my work right here for that left side triangle, and I got approximately 2.6. And then I did my work over here for the right side of the triangle, and I got that y, I labeled it a different letter, is about 5.2. So to find the length from B to C, I add x and y together. So over here, I wrote that the length of BC is really 2.6 plus 5.2, so it's approximately 7.8 in length, whatever the units are. And then the find area of a triangle is 1/2 base times height. So the base is that BC, it's that 7.8, and the height is the 3. And I just entered it into my calculator and found the area is about 11.7. So you're on your own for the problem set. There's only 6 questions, and good luck. Send us any questions if you have them, and we'll talk to you soon. See ya. Bye.